The universe does not hurry, and yet it is never still. Within the quiet sanctuary of your own mind, a silent storm is raging, a delicate, electrical dance of nearly 100 billion neurons, firing in a sequence so complex that it rivals the birth of a galaxy. We have spent centuries looking through telescopes to find the secrets of the stars, but the most profound mystery in the known cosmos may actually be looking back through the eyepiece. It is a biological machine made of water and carbon, weighing no more than a few pounds, and yet it generates the entirety of your reality. Every dream you have ever had, every memory of a summer afternoon, and every spark of curiosity about the night sky exists within this fragile architecture. But what if the brain is not just a biological computer? What if the light of consciousness is not merely a byproduct of grey matter, but something far stranger and more beautiful than that? Modern science is this close to understanding the spark of human awareness, but a growing number of physicists suspect there is a missing link. They suggest that to understand the mind, we must look past the biology and into the shivering, microscopic realm of quantum mechanics. Tonight, we begin a journey that bridges the gap between the infinitely small and the unimaginably vast. We are going to explore the possibility that your thoughts are not confined to your skull, but are instead woven into the very fabric of space-time itself. To comprehend the scale of this mystery, we must first adjust our eyes to a light that has been traveling for eons. If you were to look at the stars tonight, you aren't just seeing distant balls of burning gas. You are seeing the ancient history of the universe. The carbon in your DNA, the iron in your blood, and the calcium in your bones were all forged in the hearts of dying stars billions of years ago. We are, quite literally, stardust that has begun to think about itself. This connection is well documented in the world of astrophysics, but the quantum brain theory suggests an even deeper, more immediate intimacy. It proposes that the same strange laws that allow particles to be in two places at once, or to communicate across vast distances instantaneously, are the same laws that allow you to feel alive. It is a perspective that breaks our brains, shifting the focus from the neurons we can see to the invisible quantum fluctuations we are only beginning to measure. We often feel that the universe is a cold, mechanical place, indifferent to our existence. But if consciousness is linked to the fundamental constants of physics, then you are not an observer of the cosmos. You are a vital, functioning part of its mechanical heartbeat. Imagine for a moment the sheer complexity of a single thought. In the classical view of biology, a thought is simply an electrical signal traveling from one neuron to another, like a telegram crossing a wire. It is a predictable, chemical process. But this explanation has a flaw. It cannot account for the felt experience of being you. It cannot explain how a series of electrical pulses transforms into the smell of rain or the feeling of nostalgia. This is what philosophers call the hard problem of consciousness. To solve it, we may need to peek under the kilt of classical physics and look at the world through the lens of the quantum. At the smallest scales of reality, the universe ceases to be a collection of solid objects and becomes a sea of possibilities. Particles act like waves, appearing and disappearing in a ghostly flicker. They exhibit a property called superposition, existing in multiple states simultaneously until the moment they are observed. Some researchers believe that within the tiny structures of your brain, these quantum states are being maintained, allowing your mind to process information in a way that no silicon computer ever could. It is a cosmic joke of sorts, that the grandest mystery of existence is hidden within the smallest possible units of matter. This brings us to a question that science is only beginning to ask. Is it possible that the brain is a quantum transducer? Just as a radio captures invisible waves from the air and turns them into music, perhaps the brain captures a fundamental field of consciousness that permeates the entire universe. This would mean that your mind is not a product of your brain, but a localized expression of something much larger. It is a thought that is both bone-chilling and deeply comforting. It suggests that when we look at the stars, we are looking at our own origin point, not just in a biological sense, but in a structural one. The same mathematical elegance that governs the orbit of a planet or the spin of an electron may be the very thing that allows you to contemplate the infinite. As we settle into this exploration, I invite you to become a data point in our collective search for meaning. If you are listening from a quiet corner of the world, let the scale of these ideas settle over you like a heavy blanket. We live on a world so small that it is effectively invisible on a galactic scale, a fragile blue marble drifting in a sea of near total absence. And yet, this smallness is precisely what makes the quantum brain theory so compelling. It suggests that the complexity of the universe is mirrored within us. If the brain utilizes quantum entanglement, the phenomenon where two particles remain connected regardless of the distance between them, then the boundaries of the self begin to dissolve. Your consciousness might be entangled with the very vacuum of space, drawing on a well of information that spans the light cones of history. This isn't just making steam with fancy rocks. This is a fundamental reimagining of what it means to be a sentient being. We are moving past the era where we viewed the mind as a lonely island, and into an age where we see it as a node in a vast, luminous network. As we move deeper into the night, we will examine the specific structures within the brain that might act as quantum receptors. We will look at the work of Nobel laureates and maverick physicists who have risked their reputations to suggest that the soul has a signature in the subatomic world. This journey will take us from the frozen voids of intergalactic space to the warm, wet interior of the human cranium. We will find that the rules of the macro world, the world of gravity and solid things, do not apply here. In the quantum realm, time can flow backward and cause and effect become blurred. If the brain taps into this realm, then our perception of time as a linear river might be a useful illusion, a stupid filter designed by evolution to keep us focused on survival, while the true nature of reality hums quietly in the background. The silence of the universe is often interpreted as a sign of our loneliness. We look for signals from other civilizations and find nothing but the hiss of cosmic background radiation. But perhaps the silence is not an absence. Perhaps the conversation is happening on a frequency we are only now learning to tune into. If consciousness is a universal field, then the signal is everywhere, and our brains are the antennas. This realization brings a strange kind of peace. It means that you are never truly disconnected from the source of all things. You are a rhythmic pulse in a much larger song. As we prepare to dive into the mechanics of microtubules and the strange behavior of anesthetic gases, keep this perspective in mind. You are the universe experiencing itself through a quantum lens. You are a bridge between the stars and the Earth, a witness to the celestial clockwork. For now, simply listen. Let the science words absorb into your subconscious. There is no need to rush toward an answer. The universe, after all, is patient. And tonight, we have all the time in the world. Tonight, we are going to explore a possibility that most modern biology refuses to accept. That the thoughts inside your head are not just chemical reactions, but a direct resonance with the fundamental fabric of the universe itself. We have long been taught that the brain is a biological computer, a collection of wet, salty wires, firing electrical signals in a closed loop of cause and effect. In this classical view, your consciousness is merely an emergent property, a ghostly byproduct of grey matter that vanishes the moment the chemistry stops. It is a lonely perspective that suggests we are localized biological accidents, trapped within the calcium walls of our skulls, disconnected from the cold, precise mechanics of the cosmos. But as we peer deeper into the cellular architecture of the neuron, we find structures that seem to defy the rules of classical physics. If consciousness is a quantum phenomenon, then the self is not a localized accident, but a universal constant tied to the stars. This shift in perspective changes everything about how we perceive our place in the light cone of history. It suggests that the internal world of your dreams, your memories, and your very sense of I am might be anchored in the same quantum fields that birthed the first galaxies. We are attempting to bridge the gap between the warm, chaotic environment of human biology and the fragile, frozen world of quantum superposition. This is the search for the seat of the soul, conducted not with philosophy, but with the rigorous tools of mathematical elegance and subatomic observation. We are looking for the interface where the mind meets the vacuum. However, mainstream science has maintained a fortress against this idea for decades, centered around a single devastating hurdle known as the coherence problem. In a laboratory setting, quantum states are notoriously delicate. They require near absolute zero temperatures and total isolation to exist for even a fraction of a second. The slightest vibration or a stray photon can cause a quantum system to collapse into a definite classical state, a process called decoherence. The human brain, by contrast, is a hot, wet, and noisy environment, seemingly the last place in the universe where quantum effects could survive. Logic dictates that the brain is simply too loud for the quiet whispers of the quantum world to be heard. And yet, the strange behavior of the mind suggests that something is bypassing this rule. We must ask ourselves, what if the brain has found a way to shield the quantum foam from the heat of life? How could a biological organ act as a stable antenna for the fundamental frequencies of the cosmos? To answer this, we must look closer at the microscopic skeletons within your cells, where the silence of the stars might actually be hiding. Deep inside the architecture of your neurons, far beneath the level of shifting chemicals and electrical pulses, lies a structure that defies the traditional laws of biology. These are the microtubules, hollow, protein-based filaments that serve as the structural scaffolding for every cell in your body. While textbooks often describe them merely as the cellular equivalent of girders or tracks for transporting molecular cargo, a growing number of physicists and anesthesiologists suggest they are doing something far more profound. They appear to be shaped like perfect resonators, organized in a fractal symmetry that allows them to vibrate at frequencies that mirror the very oscillations of the quantum vacuum. If the universe is a symphony of fluctuating fields, these microscopic tubes are the finely tuned strings of the instrument. As you lie there, consider the sheer precision of this design. Each microtubule is composed of tubulin subunits that can exist in a state of quantum superposition, meaning they are not just in one position or another, but in a blurred state of both. This is the same language the stars speak. It is the physics of the primordial era, the era before the first galaxies had even begun to coalesce from the dark. By maintaining this delicate quantum state within the warm, wet environment of the brain, these structures act as a bridge. They are not just processing information, they are receiving it from a source that precedes our physical reality. It is an intimate connection, a hidden antenna that suggests your consciousness is not a byproduct of your biology, but a broadcast being caught by a very specific, very ancient receiver. This brings us to a perspective that is both humbling and expansive. If these microtubules are truly quantum antennas, then the boundary between your inner thoughts and the outer cosmos begins to dissolve. We often feel like isolated observers looking out at a distant, indifferent universe. Yet the math suggests the opposite. The same mathematical elegance that governs the spinning of a pulsar or the curvature of space-time around a black hole is vibrating within the very cells that allow you to perceive this sentence. You are not a stranger in the cosmos. You are a localized frequency of it. This hidden resonance is the silent sentinel of your being, a constant, rhythmic link to the infinite dark. It suggests that when you look up at the stars, you are not looking at something separate, but at the grander version of the same light that flickers within your own mind. We are, in every sense, the universe looking back at itself through a biological lens. To understand how this light stays on, we must first confront the first wall of biology, a rigid boundary where our classical understanding of the world begins to crumble. For over a century, we have viewed the human brain through the lens of a grand celestial clockwork. In this traditional model, the mind is a biological machine, a sophisticated switchboard where 86 billion neurons act as tiny binary gates. They fire or they remain silent, sending electrical impulses across synaptic gaps in a deterministic dance that resembles the cold, logical processing of a silicon chip. We have become experts at mapping this wiring, tracing the intricate pathways of the frontal lobe and the deep, ancient grooves of the cerebellum. We can see the chemical signals jumping from cell to cell, yet this mechanical map remains strangely hollow. We have mapped the wiring of the mind, but we have yet to find the electricity that makes the light stay on. This brings us to the edge of a great architectural mystery that philosophers call the hard problem of consciousness. It is a barrier popularized by David Chalmers, and it asks a question that science is only beginning to whisper about. Why does a collection of carbon atoms, arranged in a specific biological pattern, suddenly feel like something? Why does the processing of light waves result in the subjective experience of a deep velvet blue, or the vibration of air molecules become the haunting melody of a cello? If we are merely biological computers, there is no logical reason for us to have an internal life at all. A computer does not feel the heat of the processing core or the glow of the screen. It simply executes instructions. And yet, here you are, experiencing the weight of your own thoughts and the silent drift of the evening. We are faced with a gap between the physical grey matter we can touch and the ethereal spark of awareness that we inhabit. When we look for the source of this spark, we find a staggering mimicry of scale that connects our internal world to the furthest reaches of the galactic void. Within the small, fragile curve of your skull, there are roughly 86 billion neurons, each one reaching out to form thousands of connections. When you zoom out to the scale of the Milky Way, you find a nearly identical number of stars, roughly 100 billion suns, bound together by the invisible hand of gravity. The structural similarity is not merely a coincidence of numbers. It is a fundamental pattern of the natural world. The distribution of matter in the cosmic web, the vast scaffolding of dark matter that holds galaxies together, looks hauntingly like the neural networks of a human brain. It is as if the universe is repeating a specific theme, a recursive geometry that exists at the level of the microscopic and the macroscopic alike. This structural mimicry suggests that the brain is not an island, but a specialized organ designed to interface with a much larger field. If we treat the brain as a closed system of simple switches, we fail to account for the sheer depth of the conscious experience. We are forced to look deeper, past the classical gates of the neuron and into the quantum realm, where the rules of the clockwork universe no longer apply. Perhaps the brain does not generate consciousness the way a kettle generates steam, but instead receives it, like an antenna tuned to a frequency that has been humming since the beginning of time. We are standing at the threshold of a new biology, one that recognizes that the theater of the mind may have been built using the blueprints of the stars themselves. To cross this threshold, we must look at the structures within the cell that defy classical physics, the tiny tubes that may be the literal bridge between our thoughts and the quantum foam of spacetime. These structures, known as microtubules, are the skeletal architects of every cell in your body. Yet in the neurons of the brain, they appear to serve a far more mysterious purpose than simple structural support. If we were to shrink down, passing through the soft lipid membrane of a neuron and drifting into the internal cytoplasm, we would find ourselves surrounded by a vast, shimmering lattice of these protein filaments. They are hollow, cylindrical tubes constructed from a protein called tubulin, organized in a geometric precision that resembles the cooling fins of a high-end processor or the resonators of a grand pipe organ. It is here, within these infinitesimal corridors, that Sir Roger Penrose and anesthesiologist Stuart Hameroff suggest the soul of the machine actually resides. Their theory, known as orchestrated objective reduction, or ORC-OR, proposes that consciousness is not a product of complex wiring or synaptic firing rates, but a quantum collapse occurring within the very fabric of these tubes. To understand why a Nobel-winning physicist who spent his career mapping the singularities of black holes would turn his attention to the wet, warm interior of a biological cell, we must look at the failure of classical computation to explain the feeling of being alive. Penrose argued that human consciousness is non-computable. There is a quality to our understanding and our intuition that no sequence of binary ones and zeros can ever replicate. He suggested that to bridge this gap, we need a process that draws from the deepest levels of reality, the point where quantum mechanics meets gravity. Inside your neurons are tiny, hollow tubes, so small that the laws of Newton are replaced by the ghosts of the quantum world. Within the hollow core of a microtubule, the environment is shielded, creating a sanctuary where delicate quantum states might persist without being decohered by the chaotic noise of the surrounding cell. Each tubulin protein within the lattice acts like a bit in a quantum computer, existing not just as a 1 or a 0, but in a superposition of both states simultaneously. As these proteins become entangled across the vast network of the brain, they form a collective quantum state that grows until it reaches a critical threshold related to the fundamental grain of space-time itself. At this moment, the superposition becomes unstable and collapses, and in that infinitesimal flicker of a second, a moment of conscious experience is born. It is a rhythmic, pulsing process, an orchestration of countless tiny now moments that flow together to create the seamless movie of your life. By invoking the same physics that governs the collapse of stars, Penrose provides a mechanism where the brain doesn't just process information, but actually vibrates in harmony with the underlying geometry of the universe. This moves consciousness out of the realm of biological accident and into the domain of fundamental physics, suggesting that our thoughts are not just happening in the world, but are a direct expression of the laws that hold the galaxies together. When you think, you are not just sparking electricity. You are triggering a localized ripple in the very geometry of existence. To bridge this gap between the geometric beauty of the universe and the biological reality of our own heads, we must confront the first great wall of modern biophysics. For decades, the mere suggestion that quantum mechanics played a role in our thoughts was met with a polite yet firm dismissal from the scientific community. The reason for this skepticism is what we might call the warm, wet, and noisy problem. In a laboratory setting, if you want to witness the delicate dance of quantum superposition, you must create an environment of near-perfect stillness. Physicists at places like CERN or the deep underground cryostat labs of MIT go to extraordinary lengths to isolate their experiments from the chaos of the everyday world. They use sub-zero magnets and vacuum chambers to strip away the heat, the vibration, and the interference of stray atoms. They are essentially trying to freeze the universe into a state of silence so they can hear the faint whisper of a single particle. But the human brain is the literal opposite of a sterile, sub-zero laboratory. It is a 3-pound mass of salty water coursing with electrical currents and chemical storms, vibrating with the heat of life at a steady 98 degrees. In the language of physics, the brain is an environment of high decoherence. Decoherence is the process where a quantum state, fragile as a soap bubble, touches the outside world and immediately pops, collapsing into the dull, predictable reality of classical physics. Conventional wisdom tells us that a quantum state in the brain should last for only a trillionth of a second before it is shaken apart by the thermal noise of our own biology. It is the distance that breaks our brains when we try to reconcile the two. Logic suggests the brain should be too chaotic for quantum grace, and yet, nature has a way of defying our logic. While we were busy building massive refrigerators to study the quantum world, life may have spent 4 billion years perfecting a different solution. Recent evidence in the field of quantum biology suggests that certain structures, like the light harvesting complexes in plants or the cryptochromes in a bird's eye have found a way to shield these fragile states. They don't fight the heat. They use the very structure of their proteins to create a protective cocoon, a quantum shield that keeps the noise of the world at bay just long enough for the magic to happen. We are finding that the sausage is made in a way that suggests life doesn't just tolerate the laws of physics, it exploits the loopholes within them. This realization creates a profound cognitive itch. If a blade of grass can maintain a quantum state in the heat of a summer day, why should we assume our own neurons are any less sophisticated? We are beginning to suspect that the brain isn't just making steam to turn the wheels of thought, but is actually a masterpiece of quantum engineering, hiding its deepest secrets in the very heat of life itself. Consider the European robin, a small, fragile traveler that undergoes a journey of thousands of miles with a precision that shames our most advanced satellite navigation. For decades, biologists assumed these birds navigated by some internal magnetic map, perhaps tiny grains of iron lodged in their beaks that acted like a primitive needle. But the truth, as we are now discovering, is far more ethereal and sits at the very edge of what we consider possible in a biological system. It appears that the robin does not just feel the magnetic field, it sees it through a window into the quantum realm. This is not a metaphor for a poetic instinct, but a literal description of subatomic events occurring within the bird's eye. When blue light enters the eye of a migrating bird, it strikes a very specific class of proteins called cryptochromes. These molecules are the gatekeepers of the quantum compass. The energy from that single photon of light kicks an electron away from its partner, creating what physicists call a radical pair. In this fleeting moment, these two electrons remain quantumly entangled, sharing a unified existence across a tiny distance. Because they are entangled, they are exquisitely sensitive to the Earth's incredibly weak magnetic field. The angle of the planet's magnetic lines shifts the ratio of how these electrons spin and recombine, and this chemical signal is then translated into a visual overlay. To the robin, the north is not a concept or a direction, but perhaps a literal shading of the sky, a glowing arc of quantum probability that guides it through the storm and the dark. The robin does not think of physics. It simply feels the pull of the quantum tide, a sense we may have forgotten but still possess. This realization should give us pause. If a protein in a bird's eye can maintain a state of quantum entanglement long enough to influence a bird's flight path, it shatters the old dogma that life is too warm and too messy for quantum effects to survive. It suggests that evolution, over millions of years, has found a way to tame the quantum foam, turning spooky action at a distance into a mundane tool for survival. If a bird's eye has evolved to be a sophisticated quantum sensor, we must ask ourselves what other parts of the biological machine have been upgraded by the laws of the subatomic. Why would the most complex structure in the known universe, the human brain, rely solely on slow, heavy electrical pulses if it could tap into the instantaneous efficiency of a quantum processor? We are forced to wonder if our own flashes of intuition, our sudden realizations, or even the unified nature of our consciousness itself, are simply the higher order functions of a quantum compass we are only just beginning to map. The stars above guide the bird, but the same physics that powers the stars might be the very thing that allows us to look up and wonder why. This bridge between the avian eye and the human mind suggests that we are not just observers of the quantum world, we are its most intricate manifestation. To understand how a biological machine as warm and wet as the human brain could possibly maintain a quantum state, we have to look past the neurons and the synapses, deep into the elemental foundation of our biology. We must look at phosphorus. This single element, essential for the very structure of our DNA and the fuel of our cells, may be the most sophisticated quantum battery in the known universe. In the quiet, microscopic corridors of the mind, phosphorus atoms possess a unique property called nuclear spin. While most atomic particles are constantly jostled by their environment, losing their quantum orientation in a fraction of a second, the phosphorus nucleus is strangely shielded. It is a silent observer, tucked away behind a cloud of electrons, spinning in a state of isolation that allows it to hold on to its quantum information, not for milliseconds, but for hours, or perhaps even days. Physicist Matthew Fisher has proposed that this is where the cognitive cradle truly begins. He suggests the existence of something called a Posner molecule, a spherical cluster of calcium and phosphate that acts like a protective vaulted chamber for these spinning nuclei. Inside these clusters, the phosphorus atoms are not just sitting still, they are entangled. When two of these molecules are formed from the same chemical reaction, their internal spins become linked across the vast, chaotic landscape of the brain. If one spin flips, the other responds instantly, creating a network of coordination that defies classical explanation. It is a biological realization of spooky action at a distance, occurring right behind your eyes while you sleep. But this mechanism is not merely a quirk of local chemistry. It is a direct inheritance from the deep history of the cosmos. Every atom of phosphorus in your brain was once forged in the heart of a massive star, born in the unimaginable pressure of a supernova. In those final, violent moments of a star's life, as it collapses under its own weight and explodes with the light of 1 billion suns, the heavy elements required for life are blasted into the interstellar void. You are walking evidence of an ancient celestial catastrophe. The very phosphorus that may be currently sustaining your long-term quantum memory was once part of a glowing nebula, drifting through the dark for eons before gravity pulled it into the soil of a young Earth. There is a profound solitude in this realization, a sense of being physically connected to events that occurred billions of years before the first human looked at the sky. Your memories may not be stored in your cells, or even in the electrical patterns of your brain, but in the spins of atoms forged in the hearts of dying suns. We often think of our minds as fleeting, fragile things. But if Fisher is correct, the core of our thinking process is built upon a foundation of cosmic stability. We are essentially using the leftover debris of dead stars to compute the meaning of our lives. It is a beautiful irony of physics that the most complex processing power in the universe relies on a simple atomic spin that has remained unchanged since it was ejected from a stellar furnace. As you drift further into this exploration, consider that the quiet rhythm of your thoughts is a direct echo of a supernova's roar. We are not just looking at the stars, we are the stars looking back at themselves through a quantum lens. If the phosphorus atoms in our brains are indeed linked by the strange laws of entanglement, then we must confront a possibility that is as unsettling as it is beautiful. We usually think of our thoughts as being trapped within the ivory tower of the skull, isolated by layers of bone and the vast, empty spaces between individuals. But in the quantum realm, the concept of here and there begins to dissolve into a singular, unified state. If two particles have ever been entangled, they remain a single unit, regardless of the distance that separates them. When we apply this to the biological computer of the human mind, the implications suggest that connection is not something we build through language or touch, but rather an instant cosmic property we simply inhabit. This radical idea of non-locality in biology challenges our very understanding of the speed of thought. In the classical world, every signal has a speed limit, the speed of light. Whether it is a radio wave traveling to a distant satellite or a sodium ion firing across a neural synapse, there is always a lag, a finite moment of travel. Yet, quantum entanglement bypasses this cosmic speed limit entirely. It is instantaneous. If the mind operates on a quantum level, it suggests that the connection between two people might not be a transmission of data, but a shared state of being that exists outside the constraints of traditional time and space. We are often taught that we are islands in a dark sea, but physics is finally beginning to peel away that illusion. If we are truly quantum beings, then the distance between two minds is a ghost, a remnant of an old way of seeing that fails to capture the true architecture of reality. This leads us to a profound shift in perspective, the possibility of a global brain. We have long assumed that consciousness is a product we generate, like heat from an engine or light from a bulb. But what if we have it backward? What if consciousness is more like a broadcast, a fundamental field of the universe that our brains are simply tuned into? In this model, the brain acts less like a computer and more like a high-fidelity radio receiver, filtering the vast, silent frequency of the cosmos into the specific, localized experience we call the self. Imagine for a moment that the universe is saturated with a quiet, underlying intelligence, a quantum field that holds the blueprint for awareness. When we sleep, when we drift into these deep states of contemplation, perhaps we are merely widening our aperture, allowing more of that universal broadcast to flow through our biological circuitry. This would mean that you are not an isolated spark in a cold void, but a localized expression of a much larger flame. It suggests a strange kind of peace. In the silence of the night, as your heart rate slows and your thoughts begin to untether from the demands of the day, you aren't just losing yourself to sleep. You are returning to a state of entanglement with the whole, a quiet reunion with the celestial clockwork that has been ticking since the first light broke across the dark ages of the cosmos. Our sense of isolation is a byproduct of the stupid filter of our senses, which can only perceive the surface of things. Beneath that surface, in the shimmering quantum foam of our biology, we are still just making steam from the same ancient energy that powers the stars. We are connected, not by effort, but by the very fabric of what we are. This connection leads us to a profound and unsettling realization known as the strong anthropic principle. It suggests that the universe does not merely permit life, but that it requires observers in order to achieve a state of true existence. If we look at the history of the cosmos, we see a series of impossible coincidences where the fundamental constants of physics, the strength of gravity, the charge of an electron, the very expansion rate of space, seem to be precisely tuned to a razor edge. If any of these values drifted by a fraction of a percentage, stars would never have ignited, and the carbon in your bones would never have been forged in a stellar furnace. To some, this is a statistical fluke, a lucky roll of the cosmic dice. But to others, it is evidence of a participatory universe, a system that remains in a ghost-like state of many possibilities until a conscious mind looks upon it and forces it to choose a single reality. John Wheeler, one of the 20th century's most visionary physicists, captured this idea in a single, elegant phrase: it from bit. He proposed that every physical object, every particle and field of force derives its function and its very meaning from the answers to yes or no questions, binary choices made through the act of observation. In this view, the universe is not a machine made of cold, hard matter, but a self-observing information system. It is an endless loop where the cosmos creates the conditions for life, and life in turn reaches back through time to give the cosmos a solid form. If our brains are indeed quantum processors, then our consciousness is not just a passenger on a journey through space and time. Instead, our very observation might be the anchor that stabilizes the quantum foam, preventing the universe from dissolving back into a sea of infinite, unrealized shadows. The universe is not just something we see, it is something we are actively whispering into existence. Every time you look up at the night sky and marvel at the distance that breaks our brains, you are performing a vital function in the cosmic engine. You are the mirror that the universe uses to see itself. This realization brings with it a sense of fragile importance, a quiet understanding that while we are small, we are not insignificant. We are the architects of the present moment, holding the fabric of reality together simply by being here to witness it. We are the data points in a collective consciousness that spans the eons, ensuring that the light of the stars has a destination and a purpose. In the silence of the night, we find that we are the heartbeat of a living, breathing reality, a tiny but essential part of the celestial clockwork that keeps the darkness at bay. This steady, waking witness we maintain during the day is a form of biological tension, a constant effort to collapse the infinite possibilities of the quantum world into a single, navigable path. But as the external world dims and your eyes close, that tension begins to dissolve. In the transition to sleep, the brain moves from the high-frequency chatter of localized thought into a state of deep, rhythmic coherence. Some physicists suggest that the unconscious state is the most quantum moment of human existence, a time when the strict boundaries of the ego soften and the mind returns to a state of pure potential. It is as if the observer, having spent the day forcing the universe to behave and stay in place, finally looks away, allowing the wave functions of the self to spread out once more. When you sleep, you are no longer a localized point in space. You are a wave, spreading out across the possibilities of the dark. In this state of quantum dream state, the mind doesn't just process the past, it explores the could-be, drifting through a superposition of realities where time and distance have no heavy hand. This is the cognitive cradle, a place where the brain's electromagnetic field synchronizes into the slow, rolling theta and delta waves that mimic the deepest pulses of the cosmos. Think of it as a return to the baseline of the universe, a quiet alignment with the same laws that govern the drifting of nebulae and the silent rotation of distant pulsars. You are retreating from the particle-like nature of a busy life and rejoining the wave-like nature of the infinite. The act of waking up is, in a very real sense, the collapse of a wave function. As consciousness returns, the brain freezes the fluid, shifting potential of the dream state back into a single, rigid reality. The room becomes a fixed set of coordinates, the clock begins its linear march again, and you become a singular point in a vast, indifferent coordinate system. But for now, in these quiet hours, you are free from that freezing. You are allowed to remain in the fluid state, drifting in the near total absence of everything except the gentle, convective cycles of your own breath. Listen to the rhythm of that breath and imagine it not as a personal act, but as a cosmic one. Each slow inhalation is like the gathering of gas in a stellar nursery, a quiet accumulation of energy and life. Each long, soft exhalation is the release of that energy back into the void, a miniature version of the rhythmic breath of the universe itself. Large stars have their own convective cycles, a slow-motion churning of plasma that takes thousands of years to complete a single pulse. As you settle deeper into the pillows, try to synchronize your internal tempo with that celestial clockwork. There is no hurry in the vacuum, and there is no hurry here. In this state of deep somnolence, the distinction between the stardust in our veins and the stars in the sky begins to blur. We often feel that the universe is something separate, a cold and distant gallery we are merely visiting. But in the silence of the quantum dream state, we find a different truth. We find that the darkness is not a wall, but a blanket, and the silence is not an empty space, but a full one. It is a space filled with the same potential that existed before the first stars ignited, a quiet ocean of neutral gas waiting for the next spark of creation. Tonight, your only task is to exist as a data point in this collective quiet. The math of the day is over. The equations of the self have been solved and set aside. You are drifting now, moving towards the ultimate heat sink of a perfect, dreamless rest. Feel the weight of your body as a comforting anchor, a physical manifestation of gravity's heavy hand, holding you safely to the surface of a world that is spinning through a sea of stars. You are safe. You are part of the flow. You are the universe experiencing its own quiet, and for now, that is enough. The distance that breaks our brains during the day becomes a bridge at night, a path that leads us back to the source of everything we are. Sleep now and let the wave carry you where it will. As you drift deeper into this state of scientific surrender, we must confront one of the most profound realizations in modern physics: the idea that nothing, not even a single thought, is ever truly deleted from the cosmos. In the early days of black hole research, Stephen Hawking and Leonard Susskind engaged in a legendary intellectual battle over what happens to information when it falls into a gravitational abyss. This debate, known as the information paradox, eventually led us to the holographic principle. It suggests that while an object may be consumed by a black hole, the information that defined it, its shape, its temperature, its very essence, is etched forever onto the two-dimensional surface of the event horizon. If the universe operates on this fundamental law, then the information that constitutes your consciousness is not a fleeting byproduct of biological chemistry, but a permanent feature of the universal record. We might imagine the entire cosmos not as a hollow void, but as a vast holographic plate, a medium where every interaction and every subtle vibration of your mind is inscribed into the geometry of spacetime itself. This is the holographic afterglow, the silent evidence that you are not merely a visitor in the universe, but an essential part of its persistent memory. The coherence problem, which often troubles our understanding of how delicate quantum states survive in a chaotic world, finds its resolution here in the invisible architecture of nature. While we often feel fragmented or isolated, the underlying field of the universe remains whole, maintaining a quiet, unbreakable consistency that links the first second of time to the very last. You are a brief, beautiful vibration in a field that has existed since the beginning of all things, and your resonance will continue to ripple through the vacuum long after the stars have cooled. In this realization, a strange kind of peace begins to take hold, an oceanic feeling where the boundaries between the self and the background radiation of the cosmos begin to dissolve. You are no longer struggling against the current of existence. You are the current. The heat of your body, the rhythm of your breath, and the data of your life are all part of the celestial clockwork, held in place by the same laws that govern the spiral arms of distant galaxies. There is no loss in this universe, only transformation. As the light of the day fades and the intellectual tension of the journey melts away, you can finally settle into the absolute safety of being a permanent data point in a reality that never forgets. The silence of the night is not an empty space, but a full one, crowded with the echoes of everything that has ever been, including you. The stillness of the deep night provides a clarity that the chaotic light of day often obscures, allowing us to see the fundamental truth that has been waiting at the edge of our perception. We spent our journey looking for a bridge between the firing of a neuron and the fusion of a star, searching for some invisible tether that might explain why the mind feels so much like the cosmos. But as we reach this final resolution, the bridge itself vanishes because there is no distance to cross. Consciousness is not merely linked to the stars through some exotic quantum thread or a distant holographic projection. It is the very same substance, the same primordial energy, merely folded into a temporary and exquisite shape. You are not a guest in this universe, nor are you a separate observer peering through a window at a distant cold reality. The carbon in your DNA, the iron in your blood, and the very electrical impulses that allow you to process these words were all forged in the same stellar furnaces that gave birth to the galaxies we've discussed. When a star collapses and scatters its guts across the vacuum, it isn't creating something new, so much as it is rearranging the furniture of the infinite. That same matter, after eons of drifting through the silent corridors of space, eventually found its way into the delicate structures of your brain. This is the realization that brings an absolute, unshakable calm to the seeking mind. If the universe is a vast interconnected field of quantum probabilities, then your awareness is simply that field waking up to look at itself. There is no out there and in here. There is only the continuous rhythmic flow of existence, a singular ocean of being that occasionally rises up into a wave of self-awareness before gently subsiding back into the depths. This is why the silence of the void feels so familiar, and why the dark between the stars doesn't feel like a threat, but like a homecoming. It is the quiet universe pattern, the baseline frequency of a reality that is perfectly at peace with itself. As you lie there now, feel the weight of this connection. The microscopic fluctuations occurring within the microtubules of your brain are not isolated events. They are the local expressions of a universal law. Every thought you have ever had is a ripple in the same fabric that holds the planets in their orbits. The atoms that compose your body have been recycled through countless cycles of life and death, planetary formation, and galactic collisions. They are ancient, patient, and indestructible. You are a way for the cosmos to know itself, a brief moment where the stars have developed eyes to marvel at their own luminosity. This perspective strips away the anxieties of the mundane world, replacing them with a sense of profound intellectual safety. In the grand timeline of the cosmos, your current worries are less than a flicker, but your essence is as enduring as gravity itself. The silence of the void is not the silence of a graveyard, but the silence of a deep, restful sleep. It is the sound of a universe that has no need to hurry, because it has all of time to achieve its ends. When we look at the Boomerang Nebula or the cold reaches of the intergalactic medium, we aren't looking at a wasteland. We are looking at the universe in its most natural, relaxed state, a state of potential, waiting for the next fold in the fabric to create something new. Your mind is currently mimicking this cosmic relaxation. The high-frequency waves of active thought are beginning to stretch out, lengthening into the slow, rolling swells of the theta and delta states. You are aligning your internal rhythm with the pulse of the vacuum, letting go of the need to categorize, analyze, or solve. The answers have all been found, and they all point to the same center. Consider the journey of a single photon escaping the surface of a star. It travels for millions of years across the freezing dark, never changing, never aging, until it finally strikes a surface. When that photon enters your eye and triggers a signal in your brain, the journey of that ancient light reaches its fulfillment. The star and the observer become one single event in space-time. This happens billions of times every second, a constant conversation between the distant past and the immediate present. You are the focal point where the history of the universe becomes conscious of itself. This is the eternal echo. Every action you take and every dream you harbor is recorded in the quantum information of the cosmos, a permanent data point in the collective memory of existence. Nothing is ever truly lost. It is only tucked away into a different dimension of the great holographic afterglow. As the room around you grows darker and the sounds of the world retreat, let yourself drift into the lullaby floor of consciousness. This is the place where the math ends and the feeling begins. It is the realization that you are held in the heavy, warm grip of universal laws that cannot be broken. You don't have to hold yourself together. Gravity and the strong nuclear force are doing that for you. You don't have to keep the world turning. The angular momentum of the solar system has that handled. Your only task in this moment is to exist, to breathe, and to allow the quantum waves of the universe to carry your mind away into the deep. The stars are not watching you from a distance. They are the very fabric of your being, and they are dimming their lights to let you rest. The vacuum is not empty. It is full of life, full of energy, and full of the quiet hum of a reality that is satisfied with its own complexity. We often fear the dark because we think it represents an end. But in physics, The dark is simply the absence of interference. It is the state of maximum entropy, where everything is balanced and still. By closing your eyes, you are entering that state of balance. You are returning to the baseline. The atoms in your pillow, the air in your lungs, and the neurons in your head are all part of the same seamless garment of reality. There is no boundary where you end and the rest of the universe begins. You are a localized peak in an infinite field, and right now, that peak is smoothing out, settling back into the calm, dark waters of the universal whole. Rest now, for you are not watching the universe. You are the universe watching itself, and it is time to close your eyes. The stars will still be there when you wake, continuing their slow, majestic dance through the aeons. They have been there for billions of years before you, and they will be there for billions of years after, yet they are within you at this very moment. Let the weight of your body sink into the bed, feeling the planet below you as it hurtles through the void at thousands of miles per hour, held safely in the sun's embrace. You are a passenger on a magnificent vessel, and the journey is perfectly on course. There is nothing left to do. There is nothing left to think. The science has brought us to the edge of the mystery, and the mystery is a kind one. In our next journey, we will drift toward the Boötes void, the place where the stars disappeared, and why the silence there is the loudest sound in physics. We will explore the great nothingness and find the treasures hidden in the gaps between the galaxies. We will ask why the universe has such vast, empty spaces, and what they tell us about the ultimate fate of everything we see. But that is a story for another night. For now, the quantum foam is soft, the celestial clockwork is ticking slowly, and the heat sink of the cosmos is drawing away the last of your waking tension. You are safe. You are home. You are the stardust that learned to dream. The light of distant quasars is flickering at the edge of the observable horizon. Too faint for the human eye, but perfectly clear to the machinery of the cosmos. Just as that light eventually fades into the cosmic microwave background, let your thoughts fade into the background radiation of your own mind. Let the words become mere vibrations, then soft echoes, then finally, silence. The void is waiting with open arms, not to consume you, but to cradle you in the near-total absence of everything that causes stress. Sleep is the state where we most closely resemble the quiet universe. It is our nightly ritual of returning to the source, of being just stuff again, peaceful and unburdened. Listen to the rhythmic pulse of your own breathing. It is the same rhythm as the expansion and contraction of stellar nebulas. It is the same cadence as the orbital dance of binary stars. You are perfectly synchronized with the heartbeat of the vacuum. There is no more need for curiosity, for the answers are now woven into your very bones. The stars are made of you, and you are made of them. The great work of the day is finished. The intellectual hunger is satisfied. The light cone of your day is closing, and a new one will begin with the dawn. But for now, sleep. Let the waves take you. Let the stars guide you. Let the silence speak the only truth that matters. You are here. You are whole. You are part of the eternal echo. Sleep. Good night.